What's up, everyone? My name is Devin, and this is going to be an intro-level primer to GraphQL. If you consider yourself to be pretty familiar with GraphQL, then you're probably not going to get a lot out of this. But before I get started, I just want to say thanks to everyone that's been kind of really encouraging me, specifically my wife, because she's really into the streaming community on YouTube, and I kind of wanted to step into that for myself. When I originally wanted to give this presentation to the Asheville Javascript Meetup group, I was already in the process of planning out a series of articles that brought about this presentation. I've linked them in these slides, and they're a bit more detailed than what I'm going to go over this evening. Just a little bit about me. I'm the senior front-end developer at Firefly XD that's actually located in San Francisco. I'm 100% remote, living a little outside of Asheville, North Carolina. My background is in full-stack development, but I've been building React applications since 2015. And even though I'm a front-end developer, I still like building back-end solutions, which is largely why I picked up GraphQL and decided to focus a lot of my time with it. For some reason, it seemed like there's a lot of smoke and mirrors around GraphQL. I think that's largely because of the name, and that around the same time, graph databases were being talked about. And at the end of the day, GraphQL is just an open source query language and a runtime for managing those queries. The idea is fairly analogous to SQL as a query language and a database server. And I think if you were in a position where you're describing GraphQL as a way of describing objects, then you'd probably be pretty close. GraphQL introduces a schema language that's typed. It offers 5 default scalar types of integer, float, string, boolean, and ID. Using these types, you can define the majority of the shape of your data. There are custom types, but I'm not really going to go into the details about that right now. For the purposes of the server and application, we're going to be defining 2 object types, a cat type and a location type. The cat has 2 required fields, ID and name, and 1 optional field, free. Location has 2 required fields, ID and name, and a field called cats, which is a required list of cats. Part of the schema are also input types, and they're much like object types, but they only define data moving through your application. And I'll be using them here to pass more complex objects as arguments to fields later. And when you start talking about GraphQL schemas, you're eventually going to start talking about queries and mutations. And like the names might imply, a query is going to be how we get information from our service or server, and mutation is how we modify that data. In a lot of service implementations, the named types of query and mutation are unique and parsed specifically. In these situations, the schema type may actually not be necessary, but I prefer to be concise. So I'm going to switch over to VS Code, and we're actually going to write out our schema. So like I had mentioned before, we're going to define 2 types. The first type is going to be location. And it's going to have a field of ID, which is a required type of ID. And it's going to have a field of name, which is a required string. It also has a list of cats. You might notice that I'm using exclamation marks to denote that these are required. With a list, I'm actually saying that it's a required list, and any element that exists in that list is going to be required to be a cat. And to define our cat type, it's fairly similar. It has a required string and required ID. It has breed, which is a string. And I'm also going to give it an association of a location that is also required. We go ahead and step out our 2 input types of location input and cat input. But before I fill those out, I'm going to finish stubbing out the rest of our object types. We're going to have a query type, and we're going to have a mutation type. And like I said before, I like to be concise, so I'm going to go ahead and just define the query object type, or the schema type. Let's go back and fill these things in. So when you think about an input type, you think about the fields that you're going to be providing to the server that's going to be creating the new records in your data source. So in this situation, when we create a location, we're only going to be giving it a name. Cats are pretty similar in that we're going to be giving it a name. We're going to be giving it an optional breed. I'm also going to be adding a location ID to this, which is of type ID. That's also required. That's going to be useful later when we're actually connecting these new cats that we're creating to a location that already exists. And that's largely just because of the simplicity of the application that we're using is structured that way. But that's really it. That's going to function as our schema. So we have two types, location and cat. They each have the required fields. We have two input types. Now I actually need to define the queries that we're going to be using. So for the sake of our server and application, we're only going to have two queries, which is location that returns a list of locations, and location, which has a required field of ID that also returns a location. I've specifically not required that location be returned on the location query, because if the ID is something that doesn't exist, you could potentially return something that indicates that. There are going to be two mutations. Add location, which is going to take an input type of location input that is required, and that's going to return a location also required. And there's going to be another mutation called add cat that has an input of cat input, and that's going to return a cat, and that's required too. So that's it. For the sake of this discussion, we only have two queries, we only have two mutations. Our schema is that simple. There are a number of services now that facilitate data mapping layers, effectively generating a more robust schema over some database technology. In this case, we're going to be using Prisma and MySQL. In Firefly XD, we use AWS AppSync, but that's largely because the rest of our stack is on AWS. With Prisma, we're going to be mapping a portion of our previous schema as our data model. In this case, it's just going to be the cat and location types that we've already created. I also wanted to bring attention to the GraphQL config protocol, which is defined by the Prisma team. And there are a number of third-party applications that can read these files and self-configure based on this configuration. It's really useful to ship this with your application, especially if you're working in a larger team. I'm going to be using GraphQL CLI's getSchema tool to pull the schema for our data model out into a separate file that our server will use later. You don't have to know a lot about this, just know that the underpinning service is actually completely aware of the schema that it has. And this is actually going to get that out so that our server, which is just going to be in JavaScript, can execute it later. All right, now to actually writing the service. So the first thing that I'm going to do is I'm actually going to take the schema that we've already created, and I'm going to take the two types out of that. And I'm actually going to put them in a file that already exists called datamodel.graphql. And if you had noticed before, this file is actually referenced in our GraphQL config file. And actually it's referenced in the Prisma file. And it's what Prisma is going to use to build its data model. So now that we have the data model partially set up, I'm actually going to add two directives to the ID fields, which are @unique. This is analogous to an auto increment ID in MySQL. Prisma introduces another layer of syntax on top of GraphQL that kind of lets you get a little bit more fine-tuned with what you're doing with your data model layer. So now that I've got that set up, I can actually go ahead and deploy this. So if I run yarn deploy, I have a couple of npm scripts set up already that are actually going to handle this stuff for me. But this is just going to run Prisma deploy. And if everything goes according to plan, we should see that we have two new models created at our data layer. Yeah, I did want to go back and talk a little bit about the GraphQL config, because it's actually going to be something that we'll use later to handle looking at our queries through a different application that I haven't mentioned yet. While that's running, I'm going to go ahead and add a import directive to my schema that's going to be actually interpreted by the server later on. So what this is going to do, once the service is actually deployed and I generate the underlying data model, it's actually going to import these at runtime on the server. So we can see that now the data model is being created. And I have a working service. Now if I go to GraphQL Playground, I should be able to refresh this. And actually see the schema that we've just deployed to Prisma. All right, I'll come back to that because it does sometimes take a while after it first builds. At this point, we've not actually written any executed code. We've really just defined our underlying data service and the data that goes with it. For the server, I'm going to be using Apollo Server. Again, that's largely just because that's what I'm familiar with. GraphQL Yoga is another good option that's actually built on top of Apollo Server and created by the Prisma team. One of the terms that you're going to immediately hear when you start talking about GraphQL is resolvers. In the case of our server, they're just functions that map one-to-one with our schema and define how we actually interact with the data. For our situation, we're just going to be adding resolvers for each of the queries and mutations that we've created. Each resolver has the same function signature with 4 parameters: a reference object of the request, the arguments associated with the field, a context object associated with Apollo Server, and an info object which contains execution context for the query. All right, let's jump into writing those servers now. So I've already kind of stubbed out what the resolvers are going to look like. And just to break this down a little bit, the resolvers are just a object that are going to map out those types. Like I said, it ends up being a one-to-one mapping in the case of Apollo Server. So you can see later on when I'm actually creating the server and listening that all I'm doing is providing those resolvers and our original schema that's going to be interpreted at runtime for the Prisma service. So if I go ahead, I can actually switch back over to GraphQL or GraphQL Playground, and we can get a little bit more information about what our service actually looks like. So this is the Prisma service, and this is the actual schema that's been created by Prisma from the deploy that we made at our data model. If we look at the queries that have been created, we can actually get a lot of information out of this, and we're going to be using them later. And we actually use this to pull data from MySQL through Prisma as we define our queries for our resolvers. And one of the ones that's going to be slightly different is actually the location query, because if you remember, when we created our location query, we actually specified that we want to be able to give it an ID to get a single location back. And Prisma kind of already does that for you, specifically with creating locations and cats and location and cat. And in this situation, Prisma's understanding of a location query is actually that it creates a mapping of where that receives an ID. And like I had mentioned before, if you think about a lot of GraphQL as a way of describing objects, then what you're doing is actually, in this situation, you're actually building an SQL query with GraphQL syntax. So if we go back to VS Code, we can kind of begin to write those queries out. So in this situation, I know that Prisma exists on context. So I'm just going to go ahead and use the locations query. And I'm going to be giving it the info query. And what that's going to do is actually give Prisma context to the written query that's coming from the client. It's going to let Prisma be able to resolve further types and relationships. So in situations where we're actually requesting locations or a location, and we want to further resolve the cat type, we don't actually specify a cat resolver at the level of our server. Prisma is actually going to infer that based upon the context of the query. And like we had seen in our schema, we can pass in where. And we know that the argument that we're going to be sending to this query is ID. And we can kind of do the same thing with our mutations. Prisma creates a slightly different set of verbs to actually create location within the context of the Prisma schema. And it's data. But we can just say that it's args.input, because we know the create location is actually going to have all of the information that we need. Actually, I'm going to break that out and just say name args.input. And we can do something pretty similar for add cat. We can actually use the create cat mutation that's been created by Prisma, given the data. And we're going to break it out a little bit further this time, because we know that our input type has a name. Our input type also has a breed, which in this situation, for simplicity's sake, can be undefined, and we're not really going to care. But we also know that we need to be able to connect the cat the connected location to the cat as it's being created. And if we go back to our schema and kind of take a look at that, we can see in the create cat mutation that a unique input has been created for data. And part of that also includes location with a fairly robust type. Prisma is actually giving us the ability to create locations or connect locations at the time that we execute this mutation. So what we can do is actually specify connect and then specify the ID. And we can take the location ID that's in our input type coming from the arguments and actually pass that in. And that's going to connect the location that we have to a cat. And now I should be able to start this. Oops, forgot to generate the schema. The key part of this is actually getting the schema from Prisma. So one of the things that I just did was actually build the schema from Prisma. And this is going to be what our server is using. When you saw me add the import directive to the beginning of the graph of our schema, it's actually importing the type that's been generated by Prisma that's been saved for our server now. And now if we go back to GraphQL Playground, we can actually go to the app, and we can see our schema. And this is the schema that we've defined that's going to be connecting through Prisma. If I run the locations query that we've created, then I should get back a list of nothing, because we haven't actually added a location yet. And it looks like GraphQL Playground has crashed. Give me just a moment. There we go. In executing that query, we don't actually have any locations yet, so there's nothing to see. But we can actually go ahead and run a mutation and add a new location to our data set. In this situation, I'm just giving the information directly through the input parameter. There's not a lot of illusion there. Now that we've gotten our application server up and running, we can focus on connecting a few portions of our client application to it. There are plenty of situations where a fully fledged GraphQL client isn't going to be necessary. There are a number of applications that I work on that are actually only using fetch to interact with GraphQL. In the case of our cat adoption application, I'm going to be using Apollo Boost. It's a simplified version of Apollo Client that's great for beginners that may not actually need all the configuration options that ship with Apollo Client. The first thing we'll need to do is give the app context into our GraphQL server. We'll do this with Apollo Boost and the context provider from React Apollo. Since our setup is relatively simple, we really only need to pass the URL for our local GraphQL server into Apollo client. React Apollo ships with a few useful components that handle managing the HTTP requests for our queries for us. They give us an expressive way using render props to build out queries and the result. We'll need to write the constant that is the parse string for our location queries, pass that into the query component, and build out the UI. For this, we're just going to map the return location to some UI component and display the location name. The query component also includes some context related to the query, the location, and the error properties from the arguments passed to the render function can be used to adjust what's being rendered as the query completes. And as you may have guessed, the next component we're going to be using is React Apollo's mutation component. If function is largely the same as the query component, we'll need to add our add location mutation and then pass that mutation into the mutation prop. The first parameter for the mutation's render function is bound to the execution of the mutation. In this case, I'm going to attach it to the on click of the button, which is going to execute the add location with some provided variables. Right. Switch past to VS Code. We can take a look at our client for the first time. So the first thing that we need to do is actually create a new instance of Apollo client. And our own server is running on port 4000. And that's really all we need to do. Apollo Boost is going to give you a very limited subset of what you can do with Apollo client. But like I had said before, it's really useful if you're just playing around. And then we're going to take that client and actually provide it to the Apollo provider, and then wrap that around our entire application. Because Apollo provider is using the context API, the consumer components of query mutation are going to be able to get that later on. You can see here I've defined our queries as constants of location query and location query. I've done pretty much the same thing with add cat mutation and add location mutation. The difference is that these are actually named operations. And what this lets me do is I can actually just, the named operation is what's going to be executed when I call the mutation function. And it's going to get the input from the variables parameter or the variables property in the object that I'm passing into that function. So if we take a look at our locations component, you can see that I've already imported query and locations query. And really I just need to wrap that around what is going to be the base for displaying the names of locations. And this is a pretty straightforward component. It's just a div, and it contains an input field and a button that's part of the add location component. And like I said before, this function is the mutation the query mutation components function as render props, so their children are actually executed as functions, meaning that they give you the parameters that are passed back provide context for the execution of that function. I'm going to be pulling out loading, error, and data. In this situation, I'm going to be doing something very simple, and then I'm just going to say if loading, then I need to return. I'm just going to return the string loading. And I'm going to do something similar for error. If this were in a production situation, you would probably not want to do something like this because it's not very robust. And then I'm going to actually use our data, and we know from previously running our queries that the return of this query, the topmost property is locations. I'm actually going to run that through map. and do an immediately return expression. I'm going to bring this up into that. And just to be concise, I'm going to add location.id because we know that our query is going to return all the locations and we're only going to get back two fields, the ID and the name. My routes are structured such that the location is mapped to the ID. I'm going to add that there. I'm going to go ahead and start this. But yeah, that's it. So in this situation, this query is going to execute. While it's executing, we're going to see loading. I'll actually go back to the browser real quick. And while that's compiling, you can see that the location that I added earlier was Asheville Humane Society. And like I said, this is a very simple list of names of things with a single input above it. If we were to click on this, we would actually see that we have the ability to add cats. So I could, in this situation, add a cat, and we'll say that Hugs the cat is a Japanese bobtail. And it broke. And now we're going to go and add to the add location. I've already imported the mutation component and the mutation query and location query that I need. In this situation, this component is also very straightforward. It's just a form component that has one input. Its on change updates the state property of name, and then its on click is actually going to be what we're concerned about. In this situation, we're just going to wrap the button component in our mutation component. And I'm actually going to add another thing of refresh queries. I'll go into a little bit about what I'm doing, why I'm doing this. Refresh queries is actually going to tell Apollo within the context of all of the components that are bound to that query to re-execute whenever this mutation is completed. And it's useful if you're not doing something like subscriptions. But in this situation, I just want to ensure that when I add a new location, I'm actually going to see that location immediately added without doing a lot of other state management elsewhere. And much in the same way that our query component had several parameters passed in through render props, this is actually going to function very similar. Like I'd said before, the very first parameter of the function returned in a mutation is bound to the execution of the mutation. So I'm going to go ahead and just do something pretty similar to what I did in the query component and return loading there and return error there in situations that it breaks. And then I'm actually just going to call add location. So that's actually going to pass the whole state of this component into the input argument for that mutation. That may not necessarily be ideal in a lot of situations. You might want to break it out better than that. But in this case, I know that state just contains one field that is name. and we'll leave it at that. And if we switch back over to our application, we switch back over to our application. It was actually just finding the error that I created here. So just a moment to resolve that. And it was largely because my types were mismatched. So we can see that it worked. In an ideal world, you might not want to leave that input around, but I didn't modify the state after the mutation completed, so it's not that big of a deal. We can actually go in now, and we should be able to say, no. Oh well. So yeah, this was very much a shallow dive into what you can do with GraphQL. There's definitely a lot more to be discussed, such as pagination connections, and with a little bit more effort, you can connect Prisma to an existing relational database and build GraphQL for something that you're already using. A lot of folks in the community tend to bring up that GraphQL isn't necessarily a cure-all, which it certainly brings with it its own complexity and nuance. So if you're in a situation where you're thinking about introducing GraphQL to your stack, definitely take the time to figure out if it's really what you need to solve your problem. I've referenced some of the tools I've used and a few other neat things. Like I had mentioned, I use AWS AppSync, and it's certainly something that's made my life a lot easier right now. You can also get a completed version of the server and app that I was working on at the link referenced here. So I've actually opened up chat if anybody has any questions. If not, then cool. I really appreciate you taking the time to watch this stream. This was definitely the first time that I've done this, so slight technical issues. Also, live coding sessions, things are definitely going to go wrong, as they most certainly did. So any level of preparedness that I had for this was definitely not quite enough. But again, I really appreciate it. Thanks for your time.